Elixir is awesome, and it's easy to come up with even more than 10 reasons to love it. So I just tried to quickly add some examples and decided that, okay, this might be some, open question conversation. So I only have 10 slides, 1 slide per reason. So every slide, when I describe the basic outline, everyone can just ask questions if it's not obvious for some reason why it's a good thing or anything else, whatever. So well, this is basically a virtual machine similar to GVM in some aspects, but it's much smaller, much simpler. It's super optimized. It was originally built by Ericsson to power communication equipment, which means it was by design super reliable, resilient, and everything. So the main benefit for us, because we do web development, application development, is the fact that we can spawn as many processes as we want because they're super lightweight. So it's similar to green threads, fibers, coroutines. Pretty much any language has similar concept. So it's a virtual thread that scheduled across some number of physical threads by Beam VM. It's kind of managing that, and we have no idea how it's happening. I mean, we don't have to have any idea to use it because it's all optimally managed by Beam VM. And just for numbers, because it matters, if you try to run anything on GVM, it will require minimum 300 to 500 megabytes to just run anything. And then it quickly say, okay, I'm out, memory is over, garbage collection is not working, and it just crashes. So Beam actually takes as low as 30 megabytes to just run, and it's super light. Second thing, it relies on actor model everywhere. So everything that you use from OTP is the main library of processes in Erlang and Elixir, obviously, because they share ecosystem. Everything is based on actors. What is actor is a process that can accept messages and send messages to other processes. So it's basically some entities that can talk to each other. Cool. So this is basic example how it's implemented. So you run some code, and you can use receive loop where you will pattern match versus incoming messages. So once you got that message, you exit that loop. So obviously, if you wanted to infinitely repeat, you just call it again. So this is how processes in Elixir and Erlang work. But you don't use that because this looks kind of cumbersome, and it's how would you build something more complicated? It's hard. That's why you get other abstractions like Gen Server, which we're not going to talk about today. But it's super simple. Everyone will just read documentation and start using it. So actors, you get message, you process the value, you do whatever you want. You can update the internal state with that data from that message. You run that loop again, and you wait for another message. In that processing code, you can send messages to other processes the same way. And one of the most important properties of actors is that you have a mailbox where incoming messages are actually queued. So there is no way that actor processes more than one messages at once, which is absolutely amazing for making concurrency reliable. So there's no way to run into condition race or anything like that. Okay, third one is there is a paradigm, let it crash. Many people understand it in different ways. They say, oh, okay, let it crash, fine, whatever. I have some bugs in my code, it crashes, and I'm just gonna keep it this way. I'm not gonna catch errors or anything. This is not exactly right. It means that yes, your code in some particular place might crash, and it might crash your process. But Elixir and Erlang, they have internal tools to deal with that. They have supervisors that allow you to build the tree of processes and set up strategies how to deal with that. So if your process crashes, you can say, okay, I'll just restart that process. If it crashes again, multiple times, you can have strategies that say, okay, do not restart after 10 crashes or like 20. So basically, this is embedded into language. This is an internal feature of the language that allows you to cheaply and easily build applications that heal themselves. And obviously, there are callbacks that allow you to analyze what happened and perform some actions. Okay, this is my favorite. Especially for people coming from Ruby. Elixir looks similar when you look at the syntax, but it's entirely different for the reason that there's no mutability in the language at all. None, zero. You cannot reassign variable. You can only assign it once. You can process it. You can do stuff, assign another variable. You can reassign the same name of the variable, but it's going to be shadowing. It's not a mutation. Well, how to deal with state? Now, remember, we have actors that might have internal state. So if you want something to be updatable, some entity that will contain your precious piece of information that you need to mutate somehow, you can use process. And there is a specific primitive for that. It's called agent, and it's super simple. You just spawn it, you get the process ID for that process, and every time you want to update state, you send messages there with that new value. Now, remember that mailbox guarantees that messages are coming one after the other. Well, this is the reason we make sure that there's no condition races. So we make sure that there's no weird problems that normally we would solve with mutexes and stuff like that, and semaphores. Okay, benefits of this approach are obvious. I'm not even talking about the internals of the language, because it's much easier to build the language that doesn't support mutation. I mean, when we talk about intermediate representation, it's super easy to do. But for us, users of the language, it's very beneficial in a way how we develop code. When you know that there's no mutation, then you know that your function is going to be either pure, or it will have some side effects that have to do with accessing data or HTTP requests to other services, which is all under control. So when you have pure function that takes value and returns value, it's easy to test. Because you can come up with, for example, it's going to be mentioned later, but there's a framework for testing. It's called Proper, and it's a Erlang implementation of Quick Check. Everyone heard of Quick Check, Scala Check. So it's a testing where you just shoot random values and you check if function satisfies some condition. So it's basically testing the behavior with unknown output. You just define how many tries you need to perform to make sure, okay, this function is probably working fine, and some edge cases. It looks like magic, it works like magic, but in real life, it's pretty hard to use, and you'll figure that out on your own when you try to do that in real life. Okay, testing processes is a little bit harder because all you get is a process ID, and and there's only interface. Like, what messages can you send? Will it respond or not? Will it change the internal state? To simplify testing processes, I created a little library which didn't get any traction because I never promoted anything of but it's, I mean, take a look. It's actually pretty cool. So basically, it's a probe. It's a process that you can launch, and it can do stuff on your behalf. So it's just a little wrapper around a Gen server that simplifies testing compositions of processes that are supposed to talk to each other, and you can just mimic some interface. So another process, when it talks to a third process that is supposed to respond in some way, you can just kind of mock that behavior and make sure that your process in question is working fine. This one is also the very favorite thing from functional programming. It's called pattern matching. And have anyone seen pattern matching in real life? Okay, imagine you have, oh, okay, everyone actually saw it. I remember how in JavaScript you deconstruct objects. So you just say, yes, there's a field params in my object, and you just use curly brackets params. And from that moment, in function body or in assignment, you can use later that params. So pattern matching is something similar, but it's much more powerful. You can pattern match against tuples, complex structures, and even binary strings, which is amazing when you build network protocols. So this is just an example of code of implementation of ALU. This was a lab I was doing in computer architecture class. This function signature, well, this is actually complete implementation. What it does, it deconstructs the instruction. This is actual MIPS instruction. So it deconstructs it. You can see, well, just forget about first two parameters, it doesn't matter. But this is a binary string. I say, okay, this is a signed number, 32-bit. This is also signed number, 32-bit. I assign them to variables L and R. Then I just skip 26 bits because I'm not interested in them in this configuration. And here, this is a opcode. This is just a hex number. And again, I define its length. When I call this function with this instruction, it knows that, okay, the pattern matches. I assign L and R, and I return L plus R. So it's basically a plus operation, addition operation. So you can use pattern matching everywhere, including function signature, and you can kind of overload functions in super advanced way. So you can create as many functions as you want, and it's actually pattern in Elixir. When you need to process different cases, you just create different functions for each case instead of writing case something instead of switch clause. You can also use pattern matching in assignments, but I urge you not to do that. The only place where I do that is tests, because there I want it to crash. If the pattern is not matching, whatever, test will tell me that, yeah, this is the line where this happened. Again, if it's not clear, if you try to match something incompatible in assignment, it will crash in runtime, and you don't want that.
I just want to, can you go back to slide, just comment, it took a while for me to understand what this was doing, so I'll just fill in a gap for people that are seeing this for the first time. So imagine like one function defined, and you have this thing called input, and then you have this like if statement or switch statement that says if input equals 2, comma, and then you have to destructure the input. If input is 2, and then L is 32, and sign, and like you have to check all those things in the top function, and then you say, okay, if that, then L plus R. And then you have another if statement that says, else if input is 2, do L minus R. And so this is just a way of defining the function over and over again with exactly the matches that you want in the inputs. And like what I've been saying is you're not destructuring, so you're not risking crashing or anything like that. It's pretty cool.
Yeah, and by the way, the last clause, if you take a look, it's matching anything. Yeah, and it returns 0. So yeah.
Just a quick random question there, because I was looking for the deviation of those first 2 lines to see what was difference between them. Is that last, the hex character, 0x20, that's looking to match that character 6 times at the end of 26 character?
No, it's, okay, so X, yes, 6 bits, but 20 in hex, it would be 8. Yeah, it's probably 8. Anyways, so basically you take the number that might be any size, well, depending on what type it is. So it's probably no, it's not repeating. It's cutting. So for example, you have 0, 0, 0, 1, 1, 0, but you need only 3. So you just say take 3 last bits.
Right, because hex 20 is 1 and 5 zeros.
Yeah.
And so it's specifically looking for that pattern of 1 and 5 zeros.
Yep. Okay, this is also one of my favorites of Elixir and, to be honest, programming in general. But it might be painful with Elixir, and we maybe talk about it later about pain points. But this is a part of a library I created to kind of mimic result types, and this is just a super simple macro that allows you to type OK, parenthesis something, and it kind of expands to tuple. Well, everyone knows what tuples are. Okay. So macros, you can, well, honestly, macros are exactly the same as any other language, so it's nothing special about that. Oh, another cool thing, that Elixir is kind of compilable, because you run a bytecode on Beam VM. So when it compiles, you can do some post-processing. So there are hooks that can be applied to the resulting AST. So they allow to do some extra magic.
Before you switch, what does the quote keyword mean inside that macro?
Yeah, so it's basically how you define the macros. So quote means that you just take whatever is in quote as is, and when you unwrap, you just spit it out. And obviously, unquote means that something inside of unquote, it's a variable, it's a value from outer scope. So here, it's whatever passed to macro. And it's, I said before in the discussion before the presentation that there are some limitations that feel like kind of abstractions, and it's hard to deal with. For example, you cannot pass lambda to macros, because lambda it's open to external context. It can capture something, but if you do that with macros, it's gone. It cannot access that context. Although people who created Absinthe, they kind of found a way around it, and it's terrible in a way that they made it so complicated that I don't know. I prefer. So I had a similar problem with my library that I tried to solve. And I decided not to dig any deeper, because it would create unmanageable code. And I prefer something less sophisticated, but more robust and less complicated. Okay. Something that I'm really missing in Elixir is static typing. I like type systems. I can't say that I understand them properly. So for example, this is everyone knows this is Scala, right? The logos. Okay. So 1 minute of bragging. So I'm doing my master's right now at EPFL. This is where Scala was created. Scala is a language that's working on JVM, and it's known for having super advanced type system. And the new version of Scala, Scala 3, that's coming this year or the next one, is bringing it to another level. So I like type systems because they give you guarantees, or at least confidence in your code, because they catch most of errors at the compile time. So Elixir is dynamically typed, and it feels like, yeah, what we can do with that. Fortunately, someone came up with a static analysis tool and annotations that allow you to kind of mimic typings and then check it on compile time, and it actually works pretty good. So it shows whether you call a function with compatible arguments, or you're doing something completely illegal. Yeah, this is how it looks like. Type definitions, including type variables. So you can construct more complicated types. You can use structures of the language inside of a type definition. So in this example, remember how we defined these macros? So OK error expands into a tuple with OK and value, and another tuple error value. So here's just the typing for that type. And yeah, later we can just use this type T, which is binding these two sides of it. One is successful value, another is error. It just binds them together, and when you construct more complicated spec, functional type spec, it kind of helps not to lose the shape of your data at some point, because it might happen. Okay, I probably didn't mention that, but Elixir is based on Erlang, and BeamVM is what what powers Erlang. Erlang is much older; it's from late 80s. Elixir is much younger, and it started as a macro sort of dialect of Erlang, just like CoffeeScript for JavaScript. Now it's almost independent, and Elixir people are actually contributing to Erlang community and to BeamVM development. So yeah, well, so this slide is about how we can use any library from Erlang ecosystem inside of Elixir code without any changes or adaptation. So we just call it, and we use Elixir notation. And since they share the type system completely, it's absolutely transparent. And here I just mentioned several very popular libraries that are used a lot in Elixir projects. So for example, if you heard of Phoenix, it uses Cowboy behind the scene. It uses Plug, and Plug uses Cowboy, and it's very good web server. They supported 2.0 specification long before it became mainstream. Yeah, Hackney is an HTTP client. Proper is property-based testing framework that I kind of mentioned earlier. But Elixir also has a lot of cool libraries to offer, and it's getting bigger and bigger. When it started, we basically had to use most of the stuff from Erlang, and it was not the most pleasant experience, because for some reason, first off, the syntax of Erlang is really convoluted. So the fact that you have to close the function definition with dot, they probably thought that they're super smart and they're kind of mimicking the language, the actual language as you type. in English, for example, but it's not the case. It's absolutely terrible, which actually which leads to the way documentation looks like in Erlang. It's terrible. It's hard to read, and it's so I try not to do that. I mean, only when I really need to. So these are amazing projects from Elixir. Everyone knows Phoenix. Ecto is the data layer, which is absolutely amazing. So I'm just gonna talk a little bit about the comparison with Active Record from Rails, so you understood my excitement about it. So with Active Record, well, first off, it's an object, and every time you populate the record, you instantiate that object, and it's huge. It contains a gazillion of methods that you probably will never use. Well, obviously not the code, but reference it. But still, it's an overhead, and you wouldn't want to do that. With Ecto, it's completely functional. Whatever you get from database is a structure, and it doesn't have anything connected to it except the data and the shaped inside that you defined previously. All operations are provided as modules and functions. And honestly, absolutely everything in Elixir are modules and functions. You don't deal with any weird stuff that some special cases. Everything is function that resides in some module. So it's super easy. Flow is another interesting project. It's for processing streams using back pressure technique. So it's basically whenever you have computing powers to process something, you just say, okay, give it to me. If not, it just stays. And people manage to, if you're interested, try to Google benchmarks of flow. People manage to handle millions of items on one machine in like super short time. It's pretty amazing. Right, I actually forgot to include one slide, and the next package will be about that. So BeamVM is not only great at managing internal processes, that light processes, but it's also great in combination with other instances of BeamVM. So they can pretty much talk to each other natively by using some protocol that I don't know how it works, and I don't care because it's super transparent. So you can spawn as many instances of BeamVM as you want, and you can connect them together into cluster. Before, it was kind of not super easy to do. So you would have to manage a secret token that you would have to supply to each node. Each node would have to know how to reach another node by providing the address. So Swarm is a library that kind of simplifies the management of these sort of clusters. Well, the last one is probably the most important one. Most of Elixir community came from Ruby. Ruby community is famous for being super nice to people, super friendly, super open. I don't know what community might kind of compete with Ruby in that way, because I mean, C people would not even talk with you if they suspect that you're a newbie, or C++. Rust people probably, oh sorry, Scala people, you need to be a PhD so you could talk to them like sitting at the same table. So again, Elixir is keeping this nice and open spirit. So the creator of the language, Sevalim, he is personally answering even stupid questions, and that's true. It happened to me because everyone asks stupid questions. So this, to be honest, should be the first slide, because this is the most important feature of the language, the benefit. Well, that's pretty much it. And the last one is just some libraries I created. Feel free to kind of write trash in the issues. What's that?
That state machine package, have you used it?
It's so I can actually I can show the part of documentation for that package because it's a nice one, and I just published it and it's not ready.
Okay.
But it's pretty interesting what's happening. Who used AASM in Ruby?
What does it stand for?
It's something state machine. Okay, who knows about state machines? Okay, super, okay. And I'm not talking about, okay, it kind of relies on mathematical definition of the mathematical way to describe computations as theoretized by Turing, but it's more about how we describe business processes. Let's talk about the cart in e-commerce store. So it might be in some states. First, when it's empty, you just created it. Then when you want to check out, you don't want to be able to add more stuff there because it would break the might break the logic. So you want to control the state. And the way we transition from one state to the other is events. And normally, in mathematical sense, you just have some states and you have some events that move the current state between these possible states. So this is the example of definition of state machine. Yeah, let's try. I'll scroll. So you can think about any object from the physical world, object, or in this case, it's a cat. It's an animal. So it can be in some particular states. Well, in this case, it's sleeping, or it's awake, or it's playing, or it's eating. And by defining these states, I first off, I guarantee that it cannot be in any other state. So it's locking my logic into manageable, small kind of piece of information. Then I define transitions. Okay, first I define events that can drive, that can change states from some state to the other state. Again, when I define events, it also locks my logic into some manageable kind of entity. Well, in this case, for example, the simplest event is wake. So we can move cat from sleeping to being awake. So when I apply that event, and the current state is asleep, it will move to that state because there's nothing that would obstruct this transition. More complicated cases are, for example, next event is give a mouse. Well, you see that there are 3 possible transitions, and only states from which this transition might happen are awake and playing, which means that if you have a sleeping cat and you give it mouse, it will not notice it. So it's just a reflection of the logic, how it's supposed to be in the real world. Okay, but what if you give the mouse to a cat that is awake? Now I introduce conditional transitions. In case if it's hungry, it might eat it. In case if it's not hungry, it might play with it. which means that by defining this condition, we can kind of introduce kind of non-deterministic transition. It's not non-deterministic, obviously, because we determine it by the condition. But the idea is that you can go from awake to either playing or eating, depending on if the cat is hungry. And there's a lot of nice features around it. So, for example, this state machine implementation will check itself automatically. So when you define it, it will crash on compile time if something is not right. For example, if you have one event where transitions are happening from the same state to different states without guards. So these conditions called guards. Why? Because you don't know which one to take. So if you give a mouse to the cat and it's awake, and you have transition to playing or eating and no guards, how can you tell which way to choose? So it's impossible. And this code will check that, and it will crash if something like that is present there.
Yeah. Okay.
Just to further understand, so for example, you give a mouse, you transition from awake to playing, you have a guard, so cat's not hungry, so we go from awake to eating, right? And so it would execute that one. And then it's going to also execute the third one because only if you've gone to playing.
So it's not going to execute anything. So these clauses are resolved at the time when you choose if it's ever possible. Okay. There's a function. There's a concept of introspection of state machine, and it's really useful in real life because, for example, you might want to need in advance what actions can you apply right now without applying those actions. So this resolution of possible transition is based on introspection. So it's like this way I kind of, I don't know, save strokes because I just already have this introspection, and now I use it to determine the possible transition. So in this case, yes, it will consecutively scan transitions until it finds one. That is enough. So for example, if it's not hungry, the first one will be taken, and we're done. We're not scanning anything. Yeah.
So this is a way of describing possible states exhaustively, so there's no default, and the ability to describe exactly how they're able to transition, right? And the best example I can think of is like a stoplight. Yes. You have like red, yellow, and green, and you're saying that it can only be those three, only one at a time, can't be two lights on at the same time. Yes. And it can only transition one way, like green to yellow, and then yellow can only go to red, but only after 5 seconds or more have passed. And then from red, you can only go to green. And then you can probably compose those even further. So there's all the traffic lights on one street, and if this light wants to change from red to green, it first can only do that if the other light that's perpendicular to it is not green. Otherwise, serious consequences would happen, right? Yeah.
Yeah, absolutely. And you can introduce any logic, like, okay, I'm going to scan the area before the intersection. If there are no cars, I'll extend the duration of the opposite light, and this all can be encoded in this thing. Another interesting part is that there are two ways of thinking about state machines. One is a structure. So you have this structure, you apply some rules, you get new structure. Another way is to think about it as a process. Imagine if you would have the process at hand that you could shoot events at, and it would update its own state and respond something or whatever. So with this library, I try to kind of implement both approaches. So first, you get this DSL to describe state machine. It returns definition of state machine. Then you have functions to apply events, which called trigger or something, and then this definition can be converted into Elixir process that you can launch, and it will behave like a state machine by processing all these incoming events.
And then you could spawn a million mice and see what they do with each other.
Yeah.
One more quick question. So I'm guessing you've used Scala, right? I'm guessing you've used Scala?
Yeah, well, honestly, this is weird, but I don't really use Scala in professional kind of work. So I use Scala only at school.
Okay. So if we wanted to set up like a backend or a program, and we know that we want to use a functional language, what is the, are there any particular features that you would argue to choose Elixir over, say, like F# or Haskell or Scala?
Okay, that's a good question. Elixir is much simpler. It's much smaller. To be honest, it's almost dumb, and it's super easy to deal with. So a couple of years ago, 3 years ago, I think, I was considering where to move my application I was working on. It was written in Ruby, Rails, and everything, and I was pretty much the only person who was responsible for that app for the whole its life. So if there was any technical debt, I was the one to blame. And I was kind of choosing between Elixir and Scala. And my understanding of both languages were pretty much on the same level. And I thought, okay, Scala is fancy, and maybe later I'll get a high-paying job for it if I use it. Why not? So I tried to do that with Scala. And I immediately, first day, I ran into some stuff I couldn't find the answer to. Scala is very good language, but as I said, to use it, you have to be a pretty advanced developer already. And not only as a developer, because I mean, there are many good developers, like developers from God, that would not be able to go through Scala documentation because it's not great. So I ran into some issue. I posted the question on Stack Overflow. I can even find it right now if you're interested, probably. The point is, someone answered that question a couple of months later, and it got some, upvotes, because the question was super dumb. It was how to set up logging with Play or something. And I was like, okay, it is probably justified for a bigger company where you have developers that you can throw at these problems and they will kind of build stuff. But then I started using Elixir, and I found out that it's super easy, super fun, you can develop with it super quick. And it's, again, since it's all immutable, it's simple, and it's one paradigm, it's harder to screw up. Scala is multi-paradigm language. You can use Scala like as if you were using Java, and you will just not use any advanced features. You will just be typing Java in Scala syntax, which is obviously nicer than Java syntax. But I mean, what's the point?